I will be running a test case for our 3D Multi-Agent RRT star program by Zach and Kirk. That shows the test case for having all three robots intersect and the path resolution process. So I'm initializing it with 1500 iterations and a goal sample rate of 95. Iterations are lower than an extensive search for an optimized path just for length of the video, and the goal sample rate is 95, making each new node head towards the goal 95% of the time for the sake of finding a path for these lower iterations. So once you start running the code, the main down here, you can see obstacles are made, and then each robot 0, 1, and 2 has to run the RRT star class, which will create the path and it will create the path and return it. And then once all three are made, it'll run the multi-agent RRT in order to check for collisions. Right now it's still going through the RRT star for the first robot. Looks like the first path has been made. It shows each node, the X, Y, Z coordinates of them, and the timestamp. Looks like it took just till the 6th new node after the start to get to the goal. It took 18.56 seconds, so now the second robot is making its initial path. Since there's time, I'll show the two classes. Here's the multi-agent. There's moving obstacles. It initializes against the speeds. Looks like the second robot has found its path. It took 16.97 seconds to get to its goal. Here you can see there's a conflict resolution. And then here's the RRT star, where we initialize the iterations, goal sample rate, and so on. Alright, looks like the third robot has found its path, and all three robots have collided at 1.8 seconds as planned for the test case. So all three robots are in conflict, and now if you look at the main, that looks like a new path has been already found for the first one. So if you look down at the main, it runs the multi-agent RRT, which then off the list of RRTs will rerun and find paths, and then once the paths are found, it will pick the lowest cost solution, and that robot will take it. Looks like the second robot has found its path, and the third has found as well. So robot 0 has been modified. It found the fastest changed path. It's 8.7 seconds slower, but it was better than what the other two robots had found. So now that robot 0 has found its path, robot 1 and 2 will have to replan for the same collision time from the 1.8 where all three of them were. Only the first one has changed its path. The two other are still colliding. Looks like the first robot found a new path. Second one's working on it right now. All three have found their paths now since the graphs are populated. It does look like that robot 2 found a better path than robot 1, which was only 0.74 seconds slower than its first path, which is very good. So here are the initial paths on the right side. As you can see, they all intersect right around where my mouse is, which obviously isn't going to work very well since these robots have mass and can't go through each other. So the final paths here, as you can see, they take different directions very early because that's when their collision happened, but they don't collide anymore, and they safely get to their goals without conflict, avoiding obstacles, and yeah, that's that.